Okay, so welcome back to ENS161 Statics of Rigid Bodies. We are now at Module 4, Friction. So welcome for this fourth module. So for this lesson, we will be dealing friction and its applications to common engineering situations. So by the end of this module, you should be able to first define what is a friction, determine the types of friction, and analyze equilibrium of various rigid bodies and structures assuming friction at the surfaces of contact. So we are still in the equilibrium of rigid bodies. So since this is statics of rigid bodies, so our problems or uh, structures to analyze are in equilibrium. So this is in the application of friction. So we'll be involving friction forces na. So that is the contact. So friction is being created when a two bodies in contact with each other. So dun sa surface na in contact nila, nandun yung friction. So malalaman natin yung friction sa next slides. Okay, so we have mentioned surfaces. So on that surface that's in contact between the surface in contact between the two bodies, nandyan yung friction. Now for this lesson, we will assume that all surfaces in contact were either frictionless or rough. So meaning frictionless meaning zero friction or say madulas siya, or which is pag nag-contact ng dalawang bodies, mag-slide lang siya without any friction or any resistance. And rough is yung, so yung rough, no, so may friction or may resistance. So friction is somewhat, so alam ko naman, no, na alam niyo na kung ano yung friction. So but friction is parang ano siya, parang resistance between the two surface. So the lower the resistance, meaning maliit yung friction, but pag malaki yung resistance between the two is especially pag rough, is malaki yung friction between the two surfaces. So if they were frictionless, the force each surface exerted on the other was normal force to these surfaces, and the surfaces could move freely with respect to each other. No, so yung sabi ko na walang resistance. So yung reaction niya is normal force lang. So since this is in equilibrium, so parang kumbaga sa roller. So roller is in contact with the like sa ground. So yung roller is assumed to be frictionless. So that's why yung reaction lang niya is isang reaction lang sa roller. So normal force or normal lang na reaction. That is the vertical reaction or the perpendicular dun sa surface. And it can move freely against each other. Now, if they were rough naman, it was assumed that tangential forces could develop to prevent the motion of one surface with respect to the other. So, there is a force developed that prevents the two surfaces that to slide or to move or create a motion between the surface. Now, tangential force example of the tangential forces na tinutukoy dito is the friction forces. So friction forces is a tangential forces that is developed when two forces or two bodies are in contact and one attempts to move one surface with respect to the other. So say you have a box, so yung box nasa floor, and i-push mo yung box, so merong nakikreate na friction doon pag i-move mo yung box. So that will depend sa type ng material or type ng surface that is in contact. So doon magmamatter yung magnitude ng tangential forces or friction forces na makikreate between the two surfaces that are in contact. Okay, so there are two types of friction. First is dry friction, or sometimes called column friction, but it is yung pinaka-usual or common terms for this type of friction is dry friction. and the fluid friction. Now, dry friction are bodies in contact along non-lubricated surfaces. So meaning, yung mga any surface that are hindi siya walang involved na fluid like yung mga water. So water also creates friction. So nandito yung fluid friction. But for our topic na friction, we will only be taking up yung dry friction lang. So yung fluid friction is doon na siya under sa fluid mechanics, which is another subject for you to take sa mga higher courses na ninyo. Okay, so we are only limited to dry friction or solving problems involving rigid bodies which are in contact along non-lubricated surfaces, no? So yun yung scope ng topic natin sa friction. So yung fluid friction is doon na siya sa fluid mechanics magfo-fall. So yun. Next is the loss of dry friction. So since yung scope natin is for dry friction only, so meron siyang tinatawag na coefficient of friction. So yung coefficients na is a factor depending on the type of surface. So but we will first discuss yung loss of dry friction. So the loss of dry friction are exemplified by the following situation. So say we have a block of weight W is placed on a horizontal plane. So itong surface na to. So meron tayong isang say a wooden block. And yung weight na is W. So in this situation, the forces acting on the block are its weight. So yung weight niya and the reaction of the surface, that is the normal force. Ang tawag dito is normal force. So since the block is not moving or you are not trying to move it, so wala pang friction involved. It is not in motion. So static pa siya. Since the weight has no horizontal component, so the reaction of the surface also has no horizontal component. Since wala kang ina-apply na hindi mo siya ipupush or hindi mo siya ipupull, so walang horizontal component. So that means wala ding horizontal component in its reaction. So that is normal force lang yung present and yung weight. So normal force is represented by the N. Now suppose now that the horizontal P is applied on the block. So syempre parang P na hindi mo pa siya like totally in motion. In static pa siya, but meron nagre-resist na F. So if P is small, so maliit lang yung i-apply mo na force P, the block will not move, of course. Kasi parang ililin mo lang yung force mo na konti lang na force. So the block will not move and some other horizontal forces must therefore exist. Since it is not moving but you're applying a small force P, meron dapat na action-reaction. No? So when you action na P and magre-react na, there should be a reaction na force na mag-exist that can balance yung P natin. So ibabalance siya. So in this case, that is yung F natin. So this other force is the static friction force. So this force is static friction force. So that is a friction na present on the figure, but our figure is in static pa. So meaning steady siya. It is not moving. So the static friction M, or the maximum value of this friction force here is denoted by this formula, that is mu s, or coefficient of friction. So ito yung symbol ng coefficient of friction, mu s for static coefficient of friction. Yes, that is coefficient of static of friction multiplied by the normal force N. So the friction force is always related to the normal force, no? So it is differentiated lang siya by the coefficient of static friction. Now, if the force P is increased, so given this figure, so if the force P is increased and the friction force is also increases, of course, kasi it is an action reaction. So continuing to oppose P, so the opposing force for P is F. So until its magnitude reaches a certain maximum value, so that is the Fm, no? So of course, so when you're pushing a block, there is a certain maximum value where pag na meet na niyan yon is mag-start na mag-move yung motion mo. So at Fm, or the maximum value of the friction force, which is in equilibrium pa siya, no? So that is in equilibrium, but after that magiging in motion na siya. So that is yung ito namang Fk is kinetic, meaning kinetic is moving. So sa kinematics, and kinetic friction force. So meaning on this portion na is meaning nag-slide na or nagmo-move na yung body na, say, yung block natin. Now similarly, the magnitude of the friction force Fk may be put in the form mu k multiplied by the normal force. So meron tayong tinatawag na coefficient of kinetic friction. So in our problems, this is a property of the material, no? So this is usually given, yung coefficient of static friction and coefficient of kinetic friction. So but of course, since tabulated na to siya, but this is derived through experiments. So nakuha siya through experiments, but meron tayong mga available na table, or sa problem ibibigay yung mga coefficient of friction for the specific problem. So these coefficients of friction, so mu s and mu k, so they do not depend upon the area of the surface in contact, but both coefficients, so itong dalawa, is strongly dependent doon sa nature ng surface in contact. So for example, a wood, metal, or plastic, so iba-iba yung coefficient of friction depending on the nature o yung material na ginagamit natin. So and also somewhat they are also dependent dun sa current or exact condition ng surface. So depende sa surface, no? So if flat ba siya or medyo curve or crook, so magdedepende din. But in terms of coefficient of friction yung mga values nila, so there are given values depending on the material. So sample metal, so wood, so or a metal on metal, metal on wood, or metal on stone. So available yung mga coefficient of friction natin. Okay, so from the description or yung mga previous na discussion, it appears that there are 4 different situations that could occur when a rigid body is in contact with a horizontal surface. Now, first is the forces applied to the body do not tend to move the body along the surface of contact. So, meaning yung force nila is somewhat lahat vertical. So, walang horizontal force. So, we're not trying to move the body. So, hindi siya nag-move. So, meaning there is no friction force. So, meaning only normal force. So, where normal force here is P plus W. So, no friction. Yan yung first na situation natin. So, body do not move and no friction force. Now, second situation is the applied forces tend to move the body. So, but it is not actually in motion. So, parang medyo slight push lang, or you are just leaning. For example, if this is a wall, so naglilin ka lang, or no, this is a big box or big block. So if you're leaning on that block, so the force is small, kaya hindi siya nagmo-move. So, you do not tend to move the body along the surface of contact, but uh, the force is not large enough also. So, yan yung, kaya hindi siya in motion. So, the friction force, F, which has developed, can be found by solving equation of equilibrium from the body. So, using this formula, you can use the equilibrium na equation. So, since there is no evidence that F has reached its maximum value, so since in this situation, hindi pa alam no kung the P is so small that F is hindi pa na-reach yung maximum value, meaning hindi pa yung graph kanina hindi pa na-reach yung FM, yung maximum friction, no? So the equation, yun nga yung kanina, Fm equals mu s and cannot be used so to determine the friction force. So for since hindi pa siya maximum, so Px is less than Fm pa. So yung horizontal component ng P, which is Px, is less than Fm pa siya. So for the next situation, so the applied forces are such that the body is just about to slide or motion impending. So parang nasa maximum na yung Px natin, that pag dinagdagan mo pa is mag-slide na talaga siya. So, you know, so there are instances sa real life, no? So when you're trying to push a box, so kailangan mong mag-push hard, and then so nakita yung naaalap yung graph kanina, so parang mag-apply ka ng force M, pag na-reach yung maximum, biglang mag-drop. Mag-drop and then constant na yung friction force. So biglang pag magpupush tayo ng isang malaking box, so biglang maitutulak mo siya, then after dun is constant na yung force na i-apply mo, which is lesser dun sa maximum kasi in motion na yung yung block na you're trying to push. So we say sa this type of situation, so this is motion is impending. So the friction force F has reached the maximum value Fm. So we can now use the formula. So together with the normal force N, balances the applied force. This balances the normal forces. So F has reached its maximum value Fm. So both equations, so yung Fm natin and yung mga equilibrium equations is magagamit natin. So sa previous situation, hindi natin magamit yung Fm but only the equilibrium equations. So for the first situation, so the body is sliding under the action of the applied forces. So meaning the body is in motion. So that is yung Px natin or yung horizontal component is mas malaki na siya dun sa Fm. So naging Fk na siya. So that is friction, kinetic friction. So meaning nagmo-move na yung the body is in motion na. So the equation of equilibrium na, so do not apply na anymore. So since equation of equilibrium only applies on a static body, but for this situation is in motion na siya. So dito na to siya sa kinematics natin or sa dynamics. So doon na. So tayo is hanggang dito lang sa C. So but the formula is magamit natin yung formula na Fk is equals to mu k times N. So these are the 4 different situations that can occur when a rigid body is in contact with the horizontal surface. Okay, so next is angles of friction. So judging by the title, this is a friction on inclined or surfaces at an angles or at an angle. So it is sometimes convenient to replace the normal force and the friction force by their resultant R. So sa previous slides natin, the reactions are normal force and a friction force. So you can combine that reactions into a single reaction, which is the resultant. So let us consider here again a block of weight W resting on a horizontal plane surface. So since there is no applied horizontal force to the block, so yung reaction natin is N, which is also yung magiging resultant natin. So that is P plus W, or weight lang, or W lang, depende sa percent. But since walang applied forces horizontally, so our resultant is vertical siya, which is equal to the normal force. So however, so if the applied force P has a horizontal component Px and a vertical component na Py, but yung Px tends to move the block. So yun yung component where it tends to move the block. So the force or the resultant will have a horizontal component F. So yung F natin and yung vertical component na is yung N. So this is N, and yung horizontal component na is yung F, or yung Px. So sa situation na to. So but this is still in no motion. Now so magiging angle niya, so the angle of the resultant with respect to the vertical is say phi. So it is angle phi. So R will form an angle phi with the normal to the surface. So that is phi, which is less than pa siya sa phi s, or phi s yung maximum angle or yung static coefficient of friction. Now if px is further increased until the motions become impending or just about to move, so the angle between R and the vertical grows, of course. So since lalaki yung angle hanggang ma-reach niya yung phi s. So that is also the maximum force. So yung Fm natin, so Px is equal to the Fm, or yung maximum force, where the block is in motion impending, or it is about to move. It is about to about to slide or to move. So the angle between R and the vertical grows and reaches the maximum value. So the value is called the angle of static friction. So this angle, this angle na to is the angle of static friction, given that the horizontal component nung resultant natin, which is the friction, has reached its maximum value. So meaning it is motion impeding. It is about to move na talaga, like doon na siya sa pinaka-peak ng friction, that is the body is in equilibrium. So that is the angle of static friction, which is denoted as the tangent. So yung formula natin in relation to the coefficient of static friction is tangent phi s, or the angle of static friction tangent, and then is equals to the coefficient of static friction. Ito yung relation nila, no? So this is the relation. So yan yung angle of static friction. Now for the next situation, so the motion actually takes place, the magnitude of the friction drops. So pag move na siya or nag-slide na siya, so the angle phi between R and N drops to a lower value, Fk. So this is called naman the angle of kinetic friction. So from the geometry, like yung triangle natin, which is NR and Fk, angle of static friction. So we can also find that tangent phi k, or the tangent of angle of kinetic friction, is equals to the coefficient of kinetic friction. Okay, so yan yung angles of friction. So angles of friction, so meron tayong situations where we'll show how the angle of friction can be used to advantage in the analysis of certain types of problem. So consider here a block resting on a board and subjected to another force other than its weight or subjected by its weight and the reaction R. So, yung angle of friction natin dito is 0 pa siya, no? 0 pa. Okay, so weight R is equals to, or yung resultant natin is equals to the normal force, which is also equal to the weight for this diagram. Now, the board can be given any desired inclination. So, say at an inclination where angle theta, which is less than pa siya sa angle of static friction. So, dito na papasok yung importance ng or yung advantage ng angles of frictions for problems na at an inclined plane. So, where the block is in no motion or motion impending or mag-slide na siya pababa. Okay, so if the board is given a small angle inclination theta, the R will deviate from the perpendicular to the board by the angle theta and will keep balancing yung weight natin. So, yung weight is totally vertical siya, no? So, by the way, weight is always vertically downward, no? So, hindi pwedeng yung weight natin is inclined siya or hindi. Weight is totally vertical downward regardless of the position of the body of the or the block. So, it will then have a normal component and a normal component of n of magnitude n is equals to w. So, n natin is equals to w cosine theta. So, ito yung normal niya. And then, yung f naman is equals to w sine theta. Since this is in static, so, forces along this or along the plane is equals also din dito sa reaction natin, and the normal to the plane is equal din sila. So if you keep increasing the angle of inclination, motion will soon become impending. So meaning ma-reach na yung maximum na angle niya, or the theta will be equal to the angle of static friction. So at that time, the angle between R and the normal will have reached its maximum value, phi s. So yung theta natin is phi s na siya. So the value of the angle of inclination corresponding to the impending motion is called the angle of repose. So meaning, yung angle natin dito, this angle, theta, is equals to the angle of static friction, and that is called the angle of repose. So meaning, parang doon na yung pinaka maximum where after that mag-slide na yung block natin. So clearly the angle of repose is equal to the angle of static friction. So if the angle of inclination theta is further increased, that is angle of repose. So if increase pa natin, which is greater than the angle of repose, as you can see, yung R natin is papunta na siya sa dulo. So doon na siya pupunta and hindi na siya vertical. So motion starts and the angle between R and the normal drops to the lower value, phi k. Ito. So liliit na siya, and then the reaction R is not vertical anymore. So the forces acting on the block are unbalanced na siya. So mag-slide na siya. So but as I'm saying, so we are only on static na part. So this part hindi natin to i-take up na. So hanggang dito lang sa motion impending yung usual na mga problems na i-solve natin. Okay, so for problems involving dry friction, meron tayong three groups of or three types ng problem. So now, first group is all applied forces are given and the coefficient of friction are known. So we are to determine whether the body considered will remain at rest or slide. So we are required to find yung friction natin. So, did it reach the maximum friction or hindi dumating sa maximum friction or umabot na siya sa kinetic na friction. So, ito yung first group natin. So, the forces applied, so yung P, yung weight are given, yung coefficient of friction between the surface are given. So, we will now find the F na lang. And then the second group is all applied forces are given and the motion is known to be impending, meaning F is equal, if yung friction natin is maximum na, meaning Fm na siya, no? So, Fm is equals to mu s n. And then, we are to determine the value of the coefficient of static friction. So, this part naman is, we are to find yung mu s natin. So, yung coefficient of static friction. So, ito siya, this mu here. So, if the weight P and are given, so you can solve for N and also equate mo sila. So, the only unknown here is yung US natin. Now, for the last group or yung third group natin, the coefficient of static friction is given and it is known that the motion is impending and a given direction. So, we are to determine the magnitude or direction of one of the applied forces naman. So, we are given with the value of the coefficient of friction, meaning you can solve for the Fm. So, and the weight, and the only thing to find is yung P natin. So, this types of problem is like, yung question dito is, how much will you apply to move the block? So, parang ganun na type of problem. So, ayan yung mga problems na. So, as you can see, hindi nakasali yung FK or yung friction on a kinetic or yung in motion na siya. So, only in the impending motion lang na portion. Okay, so the best way to understand the topic or yung theory is to apply it in a sample problem. So, let's have a sample problems. So, problem 8.1. So, a 100-pound force acts as shown on 300-pound block placed on an inclined plane. So, the coefficient of friction between the block and the plane are mu s. This is mu. So, sa book is m yung ginamit. So, mu s is equal to 0.25 and mu k is 0.2. So, determine whether the block is in equilibrium and find the value of friction force. So, this type of problem is under yung group 1 natin. So, the coefficient and forces are given and you are to find or to determine whether the force is in equilibrium or and find the friction force. So, we have here a block, 300 pound. So, we have to determine if in equilibrium siya or nag-slide ba siya or going upward siya, no? We first determine the value of the friction force required to maintain the equilibrium. So, assuming that F is directed downward, so since 100 is less than 300, so maybe we can assume na the friction force is directed to the left downward. So, usually friction force is always opposing the applied force. So, say pababa. So, we can create a free body diagram na ganito yung ano niya. Position or draw a free body diagram ganito. So, usually in an inclined plane, we use the coordinates in this position, no? So, x is parallel to the plane or yung plane natin is the x-axis and the normal to the plane or perpendicular to the plane is yung y. So that yung gagawin na natin into components is yung weight lang. So yung ibang forces is hindi na kasi ini-shift natin yung plane natin into along with the surface or along with the inclination. So this is the slope. Okay, so first is we will find yung F natin, no? So F na in equilibrium siya. So summation of forces X. So of course F is in x-axis. So summation of forces X is equals to 0. And then yung upward to the right is positive. Okay. So, first is yung 100 natin, 100 pound minus F minus, so yung X component niya is yung 3 over 5. So, 3 over 5 multiplied by 300 pounds equals to 0. Okay, so yung F natin is, assumption pa to, no? So, F could be upward to the right or tama yung assumption natin. So, depende sa magiging result natin. So, F is equals to, so yung sagot natin dito. So, F is equals to negative 80 pounds. So, meaning, the assumption natin is incorrect. So, force F is acting upward. So, therefore, F is equals to 80 pounds upward. Ganyan. Okay. So, ito yung F natin. So, ito yung minimum force or yung force, static force, friction force required to maintain equilibrium. Now, we'll find muna natin yung N since it is unknown pa din yung N. So, summation of forces Y equals to 0. Upward to the left is positive. So, N is equals to N minus or equals. So, pwede natin i-transpose agad. So, or minus muna. N minus 4 over 5, 300. So, this is equals to 0. So, N is equals to, so N is always against the body, or that is the reaction. So, positive 240 pounds. Ganyan. So, that is the N. Now, the force required to maintain equilibrium is 80 pound force directed up to the right. So, the tendency of the block is thus to move down the plane. So, meaning, yung friction natin is to the right, upward. So, meaning, yung block is mag-slide siya pababa. So, friction force is always against sa sense of motion ng body. So, the magnitude of the maximum force which may be developed is, so Fm, so yung Fm natin, so yung maximum na is Mus times the normal force. So, this is 0.25 yung mu natin times 240. So, the maximum force is equals to yung maximum force natin. Ilan to? This is 60 pounds. Okay, so 60 pounds siya. So, since the value of the force required to maintain equilibrium is 80 pounds and is larger than the maximum value which may be obtained. So, yung maximum value, maximum value of friction is 60, meaning beyond 60 is in motion na yung body natin. So, since the force required to maintain equilibrium is 80 pounds, which is greater than 60 pounds, equilibrium will not be maintained and the block will slide down the plane. So, kasi mas maliit na yung Fm natin, meaning at 80 pounds yung F natin, the block is already sliding na. So, motion niya is pababa. Okay? So, the F actual, so yung F actual natin, so yung actual na or present na friction sa problem natin since the body is in motion is equals to the kinetic friction. So, which is equals to mu k times n. So, this is equals to 0.20 times 240 pounds. So, Fk, or yung actual natin is 48 pounds. So meaning 48 pounds. The body is in motion, no? So the sense of the force is opposite to the sense of motion. So the force is thus directed up to the right. So ito na yung motion ng F natin or yung direction niya. So it should be noted that the forces acting on the block are not balanced. So yung magiging resultant between the F and N is magiging 3. So R is equals to, so or yung needed force para mabalance yung motion or para ma-stop yung motion natin. So that is 3 over 5 times 300 minus 100 pounds. So that this is the forces along X minus 100 minus 48 is equals to 32 pounds. So ito yung force na while it is in motion. So if we add additional 32 pounds, so you can totally block the force. So say maglagay ka ng, so yung 100 is mag-add ka ng 32 para ma-stop mo yung motion niya. So if this is 132, so magiging 0 na yung magiging 0 na siya. So meaning static na yung yung body or yung block natin. Okay? So that is for the example number 1. So number 2, a support block is acted upon by two forces as shown. So that is 800 Newton downward and force P. So knowing that the coefficient of friction between the block and the incline are US is 35 and mu K is 0.25. So determine the force P required. So A is to start the block moving up the incline. So para aakyat yung plane natin. So to keep it moving up and to prevent it from sliding down. So mag-start tayo sa A. So force P to start moving the block. So this is the free body diagram. So meron tayong 800 Newton, yung force P, and yung resultant natin. So resultant is at an inclined, ito yung angle natin, no, yung mga pinakita natin na situations kanina. And then i-add mo yung 25 na inclination ng plane natin. Okay, so formula for the angle of static friction is tangent phi s is equals to mu s. So meron tayong mu s, so we can solve for the phi s. So this is equals to 0.35. So tangent inverse of 0.35 is equals to ilan? That is 19.29 degrees. So that is the mu s. Now, so for the total angle or yung theta natin na gagamitin is equals to 25 degrees plus 19.29 degrees. So this is equals to 44.29 degrees. So yan yung total angle natin or yung theta. Now, since we have three forces, so we can create a force triangle. Okay, so this is for the 800. This is the P and this is the resultant, no? So when you're creating a force triangle, it must always follow the rule na tip to tail, meaning head of the arrow and yung kasunod niya is yung tail ng arrow. So ganyan, hindi pwede na dalawang arrowhead yung magtutugma. So dapat tip to tail. So this is the 800 Newton na weight and this is the resultant R. Okay. So and this is your theta. So using the theta, we can find that P is equals to is opposite to the opposite to theta na adjacent to 800 Newton. So that is 800 Newton times tangent para mas maintindihan nyo. So, tangent theta is equals to opposite, which is yung P, over adjacent, which is yung 800 Newton. So, 800 Newton. Okay? So, P here is equals to 800 Newton multiplied by tangent 44.29 degrees. Okay, so P is equals to 780 Newton. So this is the force required to start the block moving. Okay, so for the next problem or next part is find the force P to keep the block moving up. Okay, so meaning to keep the block moving up, so in motion na yung block natin. So yung magiging angle natin of the resultant with respect to the normal is phi k na. Okay, so phi k is tangent phi k equals mu k. So we have mu k, which is equals to 0.25. So tangent inverse of 0.25 is 14.04 degrees, no? So as you can see, from 19 naging 14 siya because lumit yung fk is less than fm. Kaya lumit yung horizontal component ng r natin. Okay, so yung theta natin is magiging 25 degrees plus 14.04 degrees. So this is equals to 39.04 degrees. Now again, we will solve P using force triangle. So this is 800, this P, and this is R. So this is theta. Okay, so using the formula kanina, P is equals to 800 Newton tangent of theta, which is this time 39.04 degrees na siya. So P is equals to 649 Newton. So this is the force P required to keep the block moving, no? Okay, so next is P to prevent the block from sliding down. So hindi mo siya ipupush pataas, but just to prevent the block from sliding down, meaning steady lang siya dun sa plane natin. Okay, so this time yung R natin is ito na yung magiging position niya, no? So sa kabila na to prevent it from sliding down, yung force or yung F natin is so sa previous natin yung F is opposing dun sa P, but now is dito na yung motion ng F natin kasi that is to prevent it from sliding down. So it is normal that the resultant will shift to the right. So meaning ito na yung F natin, dito na yung component niya na F, andito yung N. Okay. So the theta here is, so still yung theta natin is 19.29. Why? Because it is impending motion, meaning yung F natin is Fm, which is on static. It is at an angle of static friction. So phi s yung gagamitin natin. So yung theta natin is equals to 25 degrees minus 19.29 degrees. So theta is equals to 5.71 degrees. Okay, so if we use a force triangle, so medyo palakihin natin, no? Kasi malit na lang yung, so this is the 800, and then yung P natin, and then yung resultant. So medyo maliit na yung P, no? So P is equals to 800 tangent 5.71 degrees. So P is equals to 80 Newton. So this is the force required para steady lang yung block. Hindi siya mag-move up, hindi siya mag-slide down. So 80 Newton. Okay? So meaning static lang siya. Static lang sa position niya. Okay. So this type of problem is, I think, belong siya sa group 3 na problem. So given yung coefficient of friction, yung applied forces, or yung weight, but hanapin mo lang is yung force P na required. Okay, so that's it for the friction, our module 4. So these are the references. And this ends our module, end of module 4. So thank you for listening and have a good day.